We're still in 5.6.1, still looking at exponential growth and decay. I'm going to look at a couple word problems right out of the book here. First one, we've got, I apologize for how messed up my book is. That looks really bad, I imagine. Population growth of Raleigh. Raleigh, North Carolina is one of the fastest growing cities in the U.S. In 2014, the population was approximately 438,000, and the growth rate was about 3.4%. And we got a couple things they're going to ask us about here. Find the function for the exponential growth, estimate the population in 2017, and when will the population be 500,000, and find the doubling time. All right, so first thing we need to do is find the equation for growth. And our formula for the equation, remember, was the population equals where the population started times e to the rate times time. And I've already put that in just to save a couple seconds here. We have, I'll go just full screen. The population in 2014 was 438,000, so we've got that for our coefficient up front, times e to the, and make sure to put this part in parentheses or it will not work. You've got 0.034, that's the decimal representation for 3.4%, times x, which will be the number of years. As always, we go to graph and we get nothing at all useful. So we've got to set our window. 0 for y min, 0 for x min. I'm not going to keep moving the word problem in front of you here, but we were asked to estimate the population in 2017, and we were told that the population started growing in 2014. So we don't have to go that many years out into the future. In fact, from 2014 to now is only about 6 years. So I'm going to leave that at 10. That's reasonable. That'll show me 6 years. How high does this need to go, though? We started at 438,000, and we're told that it's growing. So I'm going to try 500,000. Nice thing about this is if I guess wrong, nobody gets hurt. Yeah, that's not nearly high enough. See, the population started up there and went past 500,000 pretty quickly. So go back to window, and I'm going to set it for a million. What you're looking for is a window that shows what your graph is doing without showing too much empty space. Personally, I think that's too much empty space at the top for my taste, so I'm going to go back and set it for 750,000. I think that'll give me a good balance. Okay, so to find the population in 2017, all we need to do is hit trace. And then type in whatever number represents 2017. If the year we started was 2014, 2017 is only 3 years after that, so we go for year 3. And we see that the population would be 485,033, or I'd round that up to 34. If we wanted to know the population this year, it's 2020, which is 6 years from 2014, so we'd go for 6. And we'll see that the population should be around 537,119. I have no idea if that's correct or not. Second question we were asked was, when will the population be 500,000? Well, you should know from previous sections, when we're asked when will it get to something, that means go to y2, put that something in to y2, and then graph again. That gives us our horizontal line at 500,000, and we can see exactly when it hits that. If we want to find it, second, trace, 5, enter, enter, enter. And we can see that it hit it after about 4 years, 3.8 years. So by 2018, it should have hit 500,000. Okay, same as all the word problems we've done this semester with the calculator. You're either using trace or you're finding a point of intersection. Now the last thing is we want to find the doubling time. Our formula for doubling time is this, the natural log of 2 divided by r. And that's always the same. Meaning when you're finding doubling time, that is the formula we're always going to use. So natural log of 2 divided by our rate was 0.034. And that gives us 20.4. So the population of Raleigh, North Carolina should double just about every 20 years. That's all there is to it. Let's look at, do we have another one? Yeah, let's call that good for now. Come back and do another one next time.